electricity to dry out wet soil? It's not science fiction. It's called electro-osmosis. This fascinating method is helping engineers around the world solve one of the toughest problems in geotechnical construction: how to stabilize wet soil, fine-grained sands, and especially clay. Let's dive into how it works and why it matters, where it has been used, including a world-famous leaning tower in Italy. Water inside the ground plays a major role in soil behavior. It fills the spaces between soil particles, these are called pores, and adds something called pore water pressure. This pressure can actually push particles apart, weakening the soil and making it unsafe for buildings, roads, and even house sites. That's why engineers dewater soil before construction, to make it stronger, safer, and more stable. There are several ways to do this, including traditional pumping, sumps and drains, thermal drying, and of course, electro-osmosis, which is particularly effective for soils that resist other methods like clay. Basically, electro-osmosis is the movement of water through a porous material like soil due to an electric field. Here's how it works. We first insert two electrodes into the ground, the cathode and the anode. Then, we apply a direct current, electricity that flows in only one direction. Since clay particles are negatively charged, the water between them contains positively charged ions, mainly from hydrogen. These ions are attracted to the negative cathode. As they move, they drag the water molecules along. At the cathode, the water is to be collected or pumped away, leaving behind drier and stronger soils.
Inserting electrodes into the soil and passing electric current through it. Clay particles have a negative surface charge, so the majority of the ions in the water between the particles are positively charged. Electro-osmotic consolidation takes advantage of this by applying a voltage across the soil, causing the water to migrate toward the cathode, where it can be pumped to the surface.
Here's why this technique is such a game changer for clay. Clay is made of tiny, lightly packed particles with very small pores. This makes it very low in permeability. Water just doesn't flow through it easily. Pumps struggle with it. But electro-osmosis doesn't rely on gravity or big force. It includes electric force to pull water through even with the tightest spaces. It is used to stabilize soft clay foundations, increase shear strength, aid soil consolidation, and improve stability of slopes, embankments, and excavations. An example of a machine that uses electro-osmosis in dewatering soil is called the e-load. It uses non-mechanical practices in dewatering soil through difference in polarity. to carefully arrange the electrodes. The water should be drawn away from the excavation, so it's moving opposite to the structure. This dries out the active zone, improving slope stability and soil stiffness. Especially useful in deep excavations, foundations of buildings, and underground works like tunnels or subways. Compared to other methods, electro-osmosis is energy efficient. It uses less power than thermal methods. It can deliver flow rates from 100 to 1000 times faster than traditional hydraulic flow in fine-grained soils. And it's localized. It only dries the targeted area, minimizing environmental disturbance. Here's a cool real-life story. In the 1990s, engineers working to stop the Leaning Tower of Pisa from tilting further looked into, you guessed it, electro-osmosis. They wanted to stabilize the foundation by shifting water away from one side of the tower. Field tests were done, but it didn't work out as planned. Turns out, the soil beneath the tower was too electrically conductive. So instead of guiding water, the current just zipped through the soil too fast. Still, the attempt shows how engineers around the world trust electro-osmosis enough to try it on historical landmarks. Today, electro-osmosis is used in a growing number of projects, including tunnel and underground construction, retaining wall support, and embankment stabilization. And as sustainable energy becomes more rampant, there's an interest in powering electro-osmosis using solar or wind energy. This makes electro-osmosis not just effective, but increasingly environmentally friendly too. To summarize everything, electro-osmosis is a ground improvement technique which uses electricity to move water through soil. It is best for fine-grained soils, especially for clays. It is fast, energy efficient, and highly targeted. Thank you for listening.